So one thing that you're going to find sometimes with these questions, sometimes you're going to see a question that you've done in the homework before and you just feel like, oh, I know how to do these. And sometimes you're going to come across a question, when you read it, you go, ooh, I'm not sure how I want to go about this one. This is sort of one of those questions, I think. You're like, you read it and you're a little bit unsure. It's a little bit different than ones you've had before. So one of the skills that you're going to have in this unit, and it's almost like a skill, you would use this skill a lot in a physics class too. You have formulas, and so you have to decide, well, if I have formulas, which formula would be good to use? And sometimes there's more than one option. So off to the side here, I'm going to pretend I looked at my formula sheet with arithmetic series. When you have a formula sheet, you still need to know what the formulas stand for. And so far, we've had 3 formulas dealing with arithmetic stuff. We've had the general term formula. We've had 2 formulas for the sum. And so we write down the formulas, and then we have to look at our formulas and say, what are things that I know? What are things that I don't know? Is there a formula or formulas that I could use that have only one thing I don't know? Because if you could, for example, in the first formula, if you could put in everything except for one thing, then you can find that one thing. Sometimes we have a formula that we have more than one thing that we do not know. And then we can't use that formula. Okay? Now, in this case, in this example, most of these formulas are going to work to solve this. Okay? What do we need to find? We need to find term 1, term 2, and term 3. Okay? We notice in our formulas that all 3 of these formulas have a term 1 in them. So if I'm trying to solve for something, I'm like, ooh, if I could put everything else in this formula except for term 1, I could use it. Ooh, got to use the same ooh. Ooh, if I had everything in this formula except for the term 1, I could use it. Or ooh, if I had everything in this formula except for the term 1, I could use it. Okay? So, looking at formula 1, do we have Tn? And again, this is where there's sometimes confusion on students' part. It's like, what is Tn? Well, Tn is a general term. It can be any term you want, right? It could be term 1. It could be term 2. It could be term 3. Which one do we know? We know a term 15. So I'm going to put a little check mark that I could put in term 15 there. And if I put in term 15, I would also know n to be 15. Does that make sense? Right? Okay. Then the only other thing I would need if I wanted to use this formula is d. Does the question tell us d? Yes, it does. I know this. This formula would let me solve for d. Okay? If I use this formula to solve for d, I would find term 1. And if I knew term 1 and you know d, could you find term 2? Yes. Could you find term 3? Yes. Okay? Something that's a little bit interesting with this first formula is, do you know that you didn't use this piece of information? Sometimes that would make you feel, I must have done something wrong. Okay? That's because math teachers and math questions, they're hard enough to begin with that we try not to give you extra information if you don't need it, because the questions are hard enough to begin with. However, in real life, when you're solving things, you often have lots of information that you don't need. right? You go to the grocery store and you can buy 10 bananas for $2, right? How much is one banana? Oh, but apples are 30 cents each. Well, that doesn't matter that the apples are 30 cents each. That's extra information you didn't need, but it's there. So sometimes that happens. However, maybe that extra information was there because let's say you decided you wanted to try the second formula. So if you were trying the second formula, do we know S15? Yes. Then we would know N as well based on this information. Do we know term 15? Yes, I already underlined that in green. And that 15 matches with the N. Can you see that this formula wouldn't work if you knew S15 but term 14? Because the N's wouldn't match up in the formula. But in this case, when N is 15, I can use term 15 and sum 15. And then looking at the last formula, if this is the one you wanted to use, again, color coding it, we know S15, so we know N. We want to find term 1. We know D. And we would also know this N. So this is an interesting question because all three formulas will work. Okay? And some of them, now you have to make the decision which one you want to use. Okay? You'd probably decide either to use a sum formula or to use a TN formula. Most of you would probably, I'll do the sum formula first, because you see a sum in the question, you would probably be tempted towards your sum formulas as a result. Okay? So if I'm using a sum formula, now looking at my two formulas, my check marks say both of them will work. I would probably choose the first one just because it looks like there's less stuff than the second one. Does that make sense? Why not use a simpler formula if you can? So, starting that way, using the second formula, sum of the first 15, 93.75 equals, my N is 15. Term 1 is what I want to find, so it stays. Term 15 is 11.5 and divided by 2. And now we have to go back to our grade 9 algebra skills in, can I isolate the term 1? Can I solve this equation? Right? There's a couple of different options that you could do. You can decide on how you would go about solving this. Me personally, I would probably say I want to get rid of the dividing to begin with. Dividing by 2, opposite is multiplying by 2, so I multiply both sides by 2. Someone can check with the calculator to make sure I didn't make any mistakes. $187.5? Good. All right. Then, what can we do here? Well, you could either, if you wanted to get rid of the 15, it's multiplying. You could either divide both sides by 15, or you could get rid of the brackets by distributing both sides by 15. That's a choice that you have. If you distributed, because I drew the arrows, I would get 15 T1 plus 15 times that. That's what, 172.5? Someone check that. That was my, is that right? 15 times 11, okay, good. So then we have 187.5 equals 15T1 plus 172.5. I'd subtract this on both sides, and oh, that works out so nicely. Oh, wow. 15, oops. There we go. And then divide both sides by 15, and we get term 1 equals 1. Once you have for term 1, you know what D is already. Does it make sense that you can go directly from here? And the question asks for the first 3 terms in a series. A series is adding, so term 1 was 1. Term 2, add 0.75, but in a series you would write plus 0.75, and add 0.75 again, plus 2.5. Okay? Now I'm going to solve it with the first formula as well, just to see, do I get the same answer if I used a different formula? So I'll draw 2 lines here. This is just redoing the question with the first formula. So in the first formula, we're going to use T15. We know that T15 was 11.5. So 11.5 equals term 1 plus D was 0.75. 15 minus 1. So that gives us 11.5 equals T1 plus 0.75 times 14. And 0.75 times 14 is 10.5. Subtract the 10.5 on both sides, and you get term 1 equals 1 as well. Now, I'm someone who likes math, right? I've mentioned that already. You might have observed it a little bit. I already solved the question. I enjoyed solving it again. Most students are like, I got the answer. I'm not interested in doing it again. But what I find interesting in doing it again is the second formula was actually less work than the first formula. And this is counterintuitive to how I'm sort of presenting myself, right? You would think if I like math, oh, I'd like to do the one that has more work. Actually, no. Part of me liking math is I'm always looking for, oh, what's the shortest way to do this? What's the quickest way to do it? And I do more math so I can find a faster way so that I can do less math in the future. Wouldn't you want to do more? No. I enjoy finding this is the better formula between the two. And sometimes you can take the time at the beginning, right? Don't just dive into a question, right? By trying to do it too fast at the beginning, it might take you longer. Look at the formulas. Go, I could use more than one. Then make a decision which formula you would like to use. Okay? There will be some questions, and I think I have some on the pre-quiz online and on your quiz as well, where it asks for the sum, but you don't know more than, there's 2 things in the formula you don't know. So if I asked you for the sum, and I didn't tell you term 1 or the last term, you couldn't use this formula, not yet. But there might be other formulas you could use to find other information first, and then you could use this formula. For example, if I told you term 7 was 8 and D was 2, and then I asked you to find the sum of the first 14 terms, you're like, okay, I don't have term 1. So if I want to use this formula, I don't know the sum, and I don't know term 1. If I want to use this formula, I don't know the sum, I don't know the term 1, I don't know the last term. So none of my sum formulas work. But I could use the first formula to find out term 1, and then I could maybe use another formula. So that's why it's important, and this is where I say this is very much a science skill in chemistry and in physics, when you have, more so in physics, when you have lots of formulas and you have to use them, you have to analyze which ones you could use. Okay, questions for this one are 7, 10, 15, and 16 is optional because it's a challenging. So if you want to push yourself, 16 is a bit more of a challenge. Okay, we're going to do the last question together. Then I'm going to give you time to get onto the program and then time to work on these questions a little bit.